In this tutorial, I'm going to walk you through the Petstore register to the light controller on my local. So the first thing first, we need to start the light controller. I have this terminal. I'm in Network light Docker. We can use a Docker Compose to start a light controller. Everybody can do that. It's a free image from Docker Hub. Let's just run this, and you can see the controller light controller started listening to 8438. Now you can go to the controller dashboard. The first time you hit this URL, it may ask you to trust the self-signed certificate. You can see we don't have any service registered on the control panel. So let's start Petstore. The Petstore is in Network Light example 4G, REST Open API, Petstore registry. So for this Petstore, the only difference than the light code generated Petstore is in the server.yaml, the enable registry is set to true. So let's start this by building and execute the service from the command line. You can see the service started and it's registered itself. So you can see from the console a light controller, you can see this registered service. Now let's go back to the dashboard and refresh this page. You can see we have Petstore service registered and there's only one instance. The number of instances is only one, or number of node. And if you click this expansion button, you can see we have this instance protocol is HTTP and IP address is 172, blah, 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 and port number is 8443. This information can be used for service discovery. For any client or consumer to access the Petstore, you can use this information curated from the light controller to access the individual instance. Now let's take a look at the status check. There's a button for status check. You can see this is a check information because we are keep sending the HTTP request to the Petstore application, the house endpoint, to ensure this service is still alive. And this is information regarding to the check. Let's say this is the last time failed timestamp is 0, meaning it's never failed. And this is the last time execute the health check. This is a timestamp. And the service ID, protocol, address, port. TLS escape is true because we are using self-signed certificate for the service Petstore running on the local host. This is the check ID. You can see we are checking this service using this house endpoint with a service ID. This is the service ID registered from Petstore. The interval is 10 seconds. Every 10 seconds we do the health check. And this is a check ID in the system so that you can identify exactly check object in the cache. They register critical service after is 2 minutes. So if we have health check failed and that fails like now recover within 2 minutes, the service will be removed from the controller. Let's go back to the home page and you can see the server info. This server info actually is coming from the Petstore, and you can see we have a lot of information regarding to this server, even including the specification and all the modules enabled on this server, like all the components and the configuration for each component. Some of the information is it might be masked, some of them like is clear text. So this is a big server info. It also includes the JVM, memory usage, all kind of stuff in the beginning, the runtime, and then the host information, as well as the framework, which version of the framework we're using for this Petstore. This is useful for the certification for the API in the portal. At the same time, we can check if there are any violation in terms of security for the service on the centralized location. Now, this controller is running the standalone application. We have a enterprise version is part of the portal, and that one has a lot more features. This is something like we want user to start using, and to leverage this for the runtime service management, as well as registry and the discovery. If we go back to the service again, expand, you can see there is a logger config. If you click this button, you can see this is all the logger created in the logback.xml, like in the Petstore application. So you can see we have a COM network Petstore as the debugging level for the logger. Let's open another terminal to send a request to the Petstore application from here. Let's say curl-k https localhost 8443 v1/pet. You can see we got one output from the console. So this is definitely the logging level is debug for the COM network NT. Let's change this logging level. We click this button, change logging level, and you change this to arrow, let's say. Update. So this is the current logging level from the Petstore. Now, let's send the same request again. You can see nothing happens. There is no logging output from the server. So you can see we can use this to updating the logging level for each package on the target server, any server registered to the control plane. If we want to add a new package, let's say we have this, let's go back to the beginning. You can see we have this as arrow, but I do want to output something from a package under the Petstore. So let's do this. Add a new package. Network NT .petstore .handler, and then we give the login level is debug. We change this. You can see we add a new login level in the handler. Now let's run the same command. You can see we got the output from here. This is because we have the logging level to set up for this package as a debug, so that we see the log output. You can see this is a very important, like for the service running in the cloud environment. Instead, you go to each service to change the logback.xml configuration and redeploy the service. You can basically changing the log level. If you see any service got issues, you can change the logging level, change the package, and then you can see the log output from a centralized location, for example, Splunk or ERK, whatever, like you have centralized managed logging. In the lab portal, we have this logging matrix as well as tracing all integrate together. Yes, they all send information to Kafka so that we can have a generic view first from tracing, then we can drill down to matrix and logging. And if it's necessary, we can always changing the logging level to output more information, trying to debug complex applications with so many services composed a big application, and with a very complicated call stack. That's pretty much the first tutorial we introduced for user. In the next tutorial, we are going to focus on the service registry and the discovery of Light controller. Thank you. Bye.